So the total test, it comes around 12 tests, and these tests are divided into two cycles. The cycle number one, it consists of Los Angeles Abration Test on Aggregate. I will detail you uh, what are these tests. Okay, just to name this, second one is the California bearing ratio test, and then we have specific gravity test and water absorption test on aggregate, ductility test on bitumen, aggregate impact value test, bitumen penetration test, and the aggregate shape test. So the first test is Los Angeles Abration Test on aggregate. So the main objective or aim of the Los Angeles Abration Test is to find the wear and tear of the aggregate. So I'm not going detail into the experiment. I will tell you what this experiment is for and what are the main objectives of doing this experiment. So this experiment, so by definition, the Los Angeles Abration Test on aggregate is the measure of aggregate toughness and abrasion resistance, such as crushing, degradation, and disintegration. So basically, in this test or experiment setup, you have a big drum, and you will fill the aggregate into this one. So there are some specifications to be followed on taking the sample of aggregate that will be detailing during the experiment explanation. So just note this one, we will be feeding the aggregate into this drum, and we will revolve the drum for specific number of rotations. So you can see on the right hand side, you will be feeding the aggregate, and due to the rotation of the aggregates inside this drum, there will be some wear and tear happening to the aggregate. So
Digit,
yeah, ma'am. Hello.
steel balls are also inserted along with the aggregate in this experiment.
So basically, there are two types of tests. One is abrasion and one is attrition. So in the case of abrasion, you will add a specific number of steel balls into this aggregate, so it's to enhance the wearing. So so a test consisting of the addition of steel balls to this aggregate to measure the wear and tear of the aggregate is called as the abrasion test. Suppose that means if you're not adding any steel ball, if the wear and tear is occurring only due to the uh, collision or friction between the aggregate, it is called as the attrition. So in this test, we are testing the abrasion by adding the steel bolts to the aggregate and by the revolution of the drum. So you'll get the disintegrated particles, and you will measure the total wear and tear occurred to the aggregate, which will give you the Los Angeles Abration Test value. So you'll get approximately how much wear and tear happening to the aggregate. So this is useful or important in the case of roads, because once we made the roads, then the vehicles will pass on to that. So naturally, as the years pass on, there will be some wear and tear due to the application of brakes or even the passage of vehicles. So this experiment is uh, to quantify the wear and tear of the aggregates. So coming to the next experiment. So the previous one was on the testing of aggregate. The next one is California bearing ratio test, and this test is for this test is done on the soil. As per the definition, the California bearing ratio test is the penetration test meant for the evaluation of subgrade strength of roads and pavements. So before designing the pavements, we are supposed to measure the strength of the subgrade. So we can do the California bearing ratio test. Basically, the CBR test, in short, it is done on the disturbed sample. That means we are taking or extracting the sample from the site, and then we will bring to the lab. Then we will fill into this cylinder, and we will give some tamping, and then we will measure the load required for penetration. You can see the mold here. We'll be filling the soil sample into this one, and we will apply the load at the top. Okay, then you will measure the deflection occurred with respect to the application of the load. So this ratio, or this load to deflection ratio, will give you the California bearing ratio value. The details, the specific details of the experiment will be told while showing you the experiment. The next one is the specific gravity and water absorption test on aggregate. So aggregate. So in this one, the first test is on the specific gravity. It is basically the relative density of the aggregate to the water. So by definition, the specific gravity test of aggregates is done to measure the strength or quality of the material, while water absorption test determines the water holding capacity of the coarse and fine aggregate. So you have an experimental setup like this in our lab. So actually we are planning to record some videos. That means the experiment setup available in our lab, we will record the videos by performing the experiments on these uh, experimental setups, and then we will show during the next classes, coming classes. So to familiarize you, so there is a bucket is there. You will be filling the aggregate into this one, and you will take the various measurements of the weight of empty bucket, weight of bucket plus the filled aggregate. So these inputs, uh, then from these values you will find the relative density of the aggregate as the first experiment in this one. And next one is basically on finding the water absorption. So you will measure the uh, weight of aggregate once it's soaked in water. Then you will make it oven dried, so that you will get the relative water absorbed by the aggregate. That will give you some indication on the water absorption capacity of the aggregate. So the water absorption gives an idea on the internal structure of the aggregate and the strength of the aggregate. The next test is on the bitumen. Okay, so this is a ductility test on the bitumen. You can see the experimental setup, which is also available in our lab. So initially, these two mold part 1 and part 2 will be close, like, and that means this will be here. Then we will fix one part, and the second part will be moved, or or a force is applied to the second part, movable part. So the measurement means the length or the distance at which a break occurring in the bitumen will give you the ductility. So this test is mainly performed to see or to find how much the bitumen is ductile. So you know the bitumen is an important constituent for making the road, right? We'll be applying the bitumen for with the aggregate to make the surface road. So this test is done to find the ductility of the bitumen. So ductility gives a measure on the adhesive property of the bitumen. The next test is the aggregate impact value test. So you have the test setup like this, and you will be filling the aggregate into this mold, and this is a hammer like arrangement. So after filling the aggregate in this mold in 3 layers and giving the uh, tamping to the different layers, you will be uh, releasing the screw from here, and this hammer weight will fall from this height onto the uh, aggregate. So this will be repeated for the definite or the defined number of times as per the experiment. And due to the falling of this hammer from a height due to the impact of the hammer on the aggregate. This aggregate will get crushed up, and that amount of crushing will give you the indication on the aggregate crushing possibility. So the aggregate impact value is a measure of resistance of the sudden impact or shock, which may differ from its resistance to gradually applied compressive load. So this we are actually providing an impact or impact loading to the aggregate, not we are giving a compressive stress to the aggregate. So this stress is very important, or the practical application is during the usage of roads. The Due to the sudden braking of the vehicles, there will be some impact force happening on the aggregate. So this test is mainly to uh, quantify the uh, how the aggregate or the ability of the aggregate to take the impact. So next test is on the bitumen. It is the bitumen penetration test. So it is almost similar to the consistency test you done for the cement. That means you will be filling the molten bitumen into the mold, and so there are some specifications for the temperature at which the bitumen has to be poured into this one that we'll be seeing to the experiment. So basically you will fill the molten bitumen into this one, and you will see uh, the depth of penetration of the plunger for definite defined time. So this penetration test, or how much the uh, uh, bitumen allows the penetration of this needle, will give a measurement on the hardness or the consistency of the bituminous material. The next test is on the aggregate shape test. So you know that the angular shaped aggregates are giving good strength for the concrete, as well as the rounded aggregates gives good for the they're good for the workability. And also very long aggregates and very flat aggregates are not good for any application, or means for making the concrete or even the road surface. So this aggregate shape test is to find the different shape problems, or the whether the aggregate is flat or too elongated to use for the road construction. So there are two tests. One is the elongation test and one is the flakiness test. So the flakiness test is mainly the to find how much the aggregate is thin, or that means whether that is very thin. The thinness of the aggregate is measured in the flakiness, and the um, length to the diameter. That means how much it is length long. It is measured in the elongation index. So by definition, the flakiness index. So we have you can see two gauges here. One is for measuring the length for elongation, and one for measuring the flakiness. So the flakiness index of aggregate is the percentage of mass of the aggregates whose least dimension is less than 0.6 times the mean dimension. So there are some this definition won't be clear to you when I'm telling now. So while doing the experiment, it will be clear. And also I have just explained the process. In the experiment cycle 2, we have softening point test on bitumen, then dynamic cone penetration test. The third one is angularity number of coarse and fine aggregate, then determination of stripping value of rod aggregate, and the last we have flash and fire point test. So you can see the apparatus for measuring the softening point. So the softening point denotes the temperature at which the bitumen attains a particular degree of softening under the specifications of the test. This test is conducted by using the ring and ball apparatus, as you can see on the right side. So a brass ring containing the test sample of bitumen is suspended in liquid like water or glycerin at a given temperature. So you can see this figure. There is a starting point and end point. You'll be filling the bitumen in this brass rings 1 and 2, and then we will apply the temperature. So as the temperature is increasing, the bitumen will get softened, and at a particular point of time, it will melt, soften, and it will uh, come down. So the temperature at which this transition occurs is called as the softening point. So next test is the dynamic cone penetration test. So we have already seen the CBR test, which is done on the soil. The dynamic cone penetration test is an test performed on a undisturbed sample. That means we have to go to the site and test the strength of the soil. So you have an arrangement like this, and then the dynamic cone penetration test provides the measure of the material's in situ resistance to the penetration. So you'll be placing the attachment on the soil, and you will be applying some impact by the hammer. So those impact will give you some measurements on the resistance of soil to the impact. Next experiment is on the angularity number and angularity number of coarse and fine aggregate, but in lab we are testing only for the coarse aggregate, that is metal. So basically, this is to test how much the aggregate is angular. So I told already that the angular shape is good for providing the strength in the concrete. So it is to measure the angularity. So the angularity number of aggregate is the amount by which the percentage of volume of voids in it after compaction in a prescribed method exceeds 33. So it is basically by measuring the volume of voids, we can find how much angularity is there for the aggregates in the uh, taken sample. So there are some calculations for finding the angularity number. The next test is on the determination of stripping value of a rod aggregate, a test on aggregate. So you will take the sample of aggregate, then you will apply the bitumen onto the, or you will coat bitumen to the aggregate, then you will place the coated, that means bitumen coated aggregate in water for around some 24 hours. So this test is to measure the stripping, or means delamination of the bitumen from the aggregate. So how much delamination of bitumen happening from the aggregate will give you the stripping value. The stripping value of aggregates is determined as the ratio of the uncovered area observed visually to the total area of aggregates expressed as a percentage. So the delamination is measured by the visual observation. There is no other any other instruments to measure how much area is uncovered while placing the bitumen coated sample in the water. So by visual observation, we should find how much that means delamination happened to the bitumen. The last experiment is on the flash and fire point test on bitumen. So this is the apparatus for that. So we'll be increasing the temperature. It means we'll place the bitumen onto this mold, and we will uh, make it heated. So the flash point and fire point are the two important characteristics of the bitumen. In the flash point of a material, here bitumen, is the lowest temperature at which the vapor of substance momentarily takes fire in the form of a flash under the specific condition of test. So you'll be applying the temperature to the bitumen, and it will start vaporizing. And when you try to ignite this one, when a ignition happens for just second, for a short time, it is called as the flash point. And when it's the same experiment is repeated, and the fire point is the lowest temperature at which the material gets ignited and burns under the specific specified condition of the test. So when it's ignited, when you get a flash, it is called as the flash point. And the temperature at which you get a fire for short time, it is called as the fire point. So these experiments will be performed in the TE lab. So due to the current situation, we are planning to record the experiments, and the experiments will be displayed in this class, and it will be explained also in the class. So that's our way forward. So by this class, we meant to make you familiar about the various experiments that we are going to perform as part of the transportation engineering lab. From the next class onwards, we will start from the um, experiment one. So hello, ma'am.